This video will demonstrate how to add or subtract radicals. To add or subtract radical expressions, we must first review the concept of like terms. 5x plus 2x are like terms because their variable portions are identical. With radicals, it is similar. To be a like term, it must have the identical radical portion, such as square root 2 plus 4 square root 2 are like terms. You can see that the radical portion is both a square root and they both have a 2 under it, so it makes them identical. So we simply add the numbers in the front. So the answer to square root 2 plus 4 square root 2 is going to be 5 square root 2. Let's begin with a simple example. 5 cube root of 10 minus 4 cube root of 10 plus 3 cube root of 2. Now, although they are all cube root, we can see that two of them are like because they both have a 10. So we can combine these two together by simply going 5 minus 4. That's going to give me 1 times the cube root of 10. Now, I don't need to have the 1 in front. Plus, and then this would be added to it, the 3 cube root of 2. So my final answer for this could simply be written as the cube root of 10 plus 3 cube root of 2. Now let's take a look at the next one. We can see that all of these have the square root of 2 as their radical. So all three are identical. So what I'm basically going to do is take what is in front of each radical and add those together. So it would look like this. I'm going to add 3x plus 4x minus 6. Now you'll notice of these, only the 3x and 4x are common. So what I really end up having is 7x minus 6 in front of the square root 2. Because I can't combine 7x minus 6. Those are still not like terms in algebraic terms. Now the first thing is radicals must be simplified. So before you can add or subtract radicals, you need to make sure the portion under the radical sign is considered a simplified radical. So I'm going to go ahead and simplify these three radical signs. So 20, if we remember simplifying radicals, I'm going to break this up into a perfect square of 4 times 5 so that I can take the square root of 4. Now 80, let's take a look at that one. With 80, I can do 16 times 5. And with 45, I can break that up into 9 times 5. So with the square root of 4 becoming 2, I have 2 square root 5 minus 4 square root 5 plus 3 square root 5. Now I'm going to add those together. 2 minus 4 is negative 2. Negative 2 plus 3 is 1. My answer is 1 square root 5. Let's do another example. In this case, I'm definitely going to focus in on simplifying the radicals first, because they're definitely not identical, although they look similar. I'm going to start with 8. 8 I know can be the square root of 4 times the square root of 2. 32 can be the square root of 16 times the square root of 2. Now, x squared I happen to know is a perfect square, but using rational exponents I can just write the power of 2 over the fact it's a square root. And then for this one, we'll take the 50, and that's going to be the square root of 25 times the square root of 2. The x squared, I'm going to do the same thing x squared, the power over the root. So now I have 5x times 2 square root 2. Now I have 3 times 4 square root 2 minus 5 times the 5 square root 2 that I got from here. And you'll notice that the x's, 2 over 2, becomes a single x. So that means that the square root of x squared is x. And I'm going to bring that out in front, and I'm going to bring that out in front. So out front here I have 10x square root 2. Here I have plus 12x square root 2 minus 25x square root 2. So the square root 2's are all the same. So 10x plus 12x, that is our 22x minus 25x. So our answer is negative 3x times the square root of 2.